Hi, this is our class number 4 and the topic is geometry. In this slide, we'll see relative position between lines. If two lines do not intersect, they are said to be parallel. And this is the symbol of parallel line. They might intersect in a point. So this is the representation of two lines intersecting a point. But two lines may intersect in a point in a special way that the angle here is exactly 1/4 of a full turn. In this case, these lines are said to be perpendicular, and that's the symbol. So, if we have two lines that are parallel, RNS and another transverse line, we will form angles where these angles are congruent, that is, they have the same measure. These, specifically these two, are opposed by this vertex. The vertex is where the angle begins. It's the point where the opening begins. It's called vertex. Plural vertices. And this is the supplement of that angle. So if this one's 30, this one's 150. As well as this one, as well as this one, too, also like that. Angles have classifications. The angle that is less than 90 degrees, so this angle here is less than 90 degrees, this angle has to be acute. If it's exactly 90 degrees, it's said to be right. If it's more than 90 degrees but less than 180, it's said to be obtuse. If it has exactly 180 degrees, it has to be straight. And if it has more than 180, it has to be a reflex angle. All of those are figures that will have two characteristics. They are formed by segments of line, and these segments do not overlap, and it's closed. So, for instance, this is not a polygon. It's not closed. This is not a simple polygon because there is an overlapping. A polygon is said to be regular if two conditions meet, and only if two conditions meet. All sides have the same length, and all angles are congruent. We have here 6 polygons. We see that in polygon A, we have different angles, so this is not regular. In polygon B, we have different sides, so it's not regular as well. Polygon C, all angles here are the same, and all sides have the same measure. It's a pentagon. This polygon is regular. Polygon D also has angles that are the same, and the sides measure the same. If it happens, this is also regular, as it happens in polygon E and does not happen in polygon F. But these two conditions have to happen. If only one of them happens, that's not yet a regular polygon. The sum of interior and external angles. The sum of interior angles are just the ones for sure inside of the polygon, depends on the number of sides. Just reduce by 2, multiply by 180. Well, it's important to notice that it depends on also have 4 sides, sum is the same. Every interior angle has an exterior angle. It does not depend on the number of sides. The sum is always 360. Polygons have a few properties, and they are perimeter, the sum of the line segments. So let's take just sum 3 plus 3 plus this one. So this is a problem you would find doing an equation. 2, 4, then you would need to do something like this. 9 equals 4 plus 3 plus x. So x is 2, so this one is 2. Just sum 3, 3, 2, 2, 4, 5, 9, and 6. Then you find the perimeter. The area is the surface that it occupies. It pretty much determines how big it is. The number of vertices now is the number of sides in polygons. To calculate the area and perimeters, you have formulas. So I will just read a few formulas here for this rectangle with base times height. In the case of triangles, just half of it, base times height divided by 2, because you would, for instance, complete here, cut this part, and put it here. So it would be half of a rectangle. This is a parallelogram in red for the parallelogram. You have the height, the square, the sides are the same, so it's all pretty much like base times height. Since they are the same, side squared. For the rhombus, the product of the diagonals, that might be different, divided by 2, and at the trapezium, you should just calculate the average of the base. This is the large base, this is the small base, the average times height. It's pretty much like putting it to be a rectangle as well. But formulas are important in the quantitative section, but definition is more important, is even more important. So let's define the quadrilaterals. What's what? The parallelogram is a figure that has parallel sides. The rectangle, 4 right angles. The rhombus, equal sides. But the rhombus happens to be a parallelogram because the sides are parallel. The side is parallel to this one, the side is parallel to this one. The rectangle also happens to be a parallelogram. If this side is parallel to this one, this side is parallel to this one. So the square is either a rhombus, parallelogram, and a rectangle. So if you read the expression, a rectangular rhombus, you should expect to be dealing with a square. And we have also the definition of trapeze and trapezoid. It might change during the time. A few questions, they refer to trapezium, sometimes they say trapezoid. Here we have the definition, but sometimes trapezoid in GMAT also serves to describe a trapezium. So a trapezium is a specific case where exactly 2 sides are parallel. Triangles, they also have names. Due to the angle, they also have to be acute, if all angles are acute. Right, if one angle is right. Obtuse, if one angle is obtuse. So this one is acute, this one is right, this one is obtuse. They also have names with due to their sides. Might be said equilateral, isosceles, or scalene. So same sides, equilateral, 2 equal sides, isosceles, and 3 different sides, scalene. And equal sides also means congruent angles, so the length angles that have the same measure. How does it happen? Let's take a look at the right triangle. We have here an angle. Let's say that this is 40 and this is 50 degrees. So they are different. The sides are different. What's the largest side? The side that is opposed to the largest angle. So this is the largest, this is the shortest side, and this is the middle one. The triangle have an existence condition, and a triangle can only exist if any of its sides, let's pick one, let's pick this one, is between, excluding the sum of the other two and the absolute difference of the other two. If it does not happen, the triangle just wouldn't close. Right triangles are related by the Pythagoras theorem. So the square of the hypotenuse is the sum of the square of the lengths. It's important to remember two proportions, 3, 4, and 5. So any proportion that might lead to these numbers is a right triangle, and you can do the math to find the missing side. And the other important ones, 5, 12, and 13. Just pick and put into the Pythagoras theorem and try to find the result. To avoid trigonometry, we can memorize these proportions. If you see a triangle where two sides have the same length and another side is just that length multiplied by the square root of 2, we can infer that the smaller angles are 45, it's isosceles. So this is the isosceles right triangle. This is 90 opposed to the biggest side. And if you find in the proportion a given side, imagine here 10, 20, and 10 square root of 3, we can infer you also that this is a right triangle and the angles are 60, 30, and 90. Just do it by proportion. If you remember this, you won't need to solve every case using sine, cosine, tangent. That's not what we expect for the GMAT test paper. Understanding a last thing about triangles is the area of an equilateral triangle. It only depends on one parameter, and we just can do this using this example here. But it's important to notice, not the formula. The formula is important, but since an equilateral triangle would just be different other than another equilateral triangle to the left, so the sides have to be in the same proportion, the angles should be the same proportion, there is only one parameter that's correct, and this is explicit in the formula. Generically, everything can change. So if you have two sides that could change, then you have two parameters that will affect the area. So this part of the class is about circumference and circle, even though it's yet entitled polygons, but just to make you aware that this also has area and a length. But the circumference is not exactly a polygon, it's not a polygon. We don't have the tools to demonstrate these formulas, but the circumference is the border. So imagine that you're walking here. The length would be twice pi r, and it's good to remember that pi is approximately 3.14. The area is pi r squared, and the diameter is twice the radius. And if you want to calculate a fraction of the circumference, just calculate the total circumference and do the fraction. It works as well for areas. The double arc theorem says that if you have a given central angle, here that I'm going to highlight in pink, this angle is always twice the peripheral angle. This, for instance, this is 100 degrees, so this is 50 degrees. It does not matter if you want to stop by here, this angle here is also 50 degrees. So, will I use this theorem like this? Nope. It's pretty much in the definition of the semicircle. So you have this semicircle I'm gonna call here A, here B, and here C, and you could have the information that AC is 6 inches, CB is 8 inches, and it said that AB is diameter, so the center O is here. So what's the area of this circle? You could think, oh, I cannot do that. I don't know anything about this triangle. But in fact, this angle is 180, so this is half, 90. So find the diameter. Oh, I also remember the proportion, teacher. So it's 10. The radius is 5, the area 25 pi. So you can find the area of this circle just with that information. So guys, I hope you enjoyed this class. This is the end of our class number 4. Bye bye. See you in class number 5.